So logic is the study of general patterns of reasoning. Without reference to particular meaning or context, we use logic to study patterns or reasonings without having a particular meaning. It doesn't always have to give us a meaning. If an object is either black or white, and if it is not black, then logic leads to the conclusion that it must be white.
If
This is an
mute your
example.
mic.
So this is an example. Suppose if we have an object that is either black or white, logic, then it leads to the conclusion.
Husnia, your voice is sometimes coming slow, sometimes it's audible, sometimes it's not audible. Can you check if it's your mic placement?
Okay, 1 second. So we're having an example for logic. If an object is either black or white, and it is not black, the logic is then logic tells us if it is either white or black. Similarly, another example is tossing a coin. If it is a head, then logic tells us that the other conclusion is tail. Logic, in fact, is the theoretical basis for many areas of computer science, such as digital logic circuit designs, automaticity, and artificial intelligence. This is where we use logic. We use it in digital logic circuit designs, automaticity, and artificial intelligence. And for logic, there are different types. There are various types of logic: proportional logic, prediction logic, and
Husnia, can you check if your network speed is okay? Because your voice is sometimes it's fine, sometimes it's breaking up.
I will restart it.
I think it's your mic placement. I think you need to keep your mic close to your mouth. You are using an earphone?
Yeah.
Okay. So I think right now your voice was okay. Can you keep the mic just where it is now so it stays consistent?
Okay. Is it clear now?
Yeah, it is clear. Okay.
Okay. So I'll continue.
Let's just restart from this because I think most of the people did not understood here now because the voice was not clear. Okay.
What is logic? Now we need to know where to use logic. So logic is used in many fields. Some of these are in computer science, such as we use it in digital logic circuit designs, automaticity, and artificial intelligence. These are the uses of logic. And logic is not of one type. There are many types of logic: proportional logic, prediction logic, and fuzzy logic. What we're going to take is mathematical logic. Mathematical logic is a subfield of mathematics that deal with the application of logic to mathematics. Here we're applying logic. Here we're applying logic to mathematics. It will be clear. We have statements. First, we need to know what is a statement. Statement is a sentence.
Your voice is again not clear. I don't know what is happening here. Yeah, can you try one thing? Can you remove your earphones from your laptop and then try speaking? Maybe that will fix it.
So shall I speak now?
Hello?
Can you hear me now?
Yeah, we can hear you now clearly.
Okay.
Yeah.
Okay. So first we'll start by a statement. What is a statement? A statement is a sentence which is either true or false, but not both simultaneously. When we have a statement, the statement should be either true, either false. It can't be both true and false at the same time. We have examples. For example, 2 plus 2 is 4. This is a statement which is true. When we add 2 and 2, we get the result 4. So this statement is true. Another example, roses are red, which is also a true example, a true statement. The sun is a star. This is also a true statement, which is true. Now, examples for false statements. Moon is a planet. We know moon is not a planet. It is false, but it is still considered a statement since it's false. Fish is a bird. We know fish is not a bird. New York is in Paris. We also know that it's false, but it is still a statement. Now, paradox. Paradox is a sentence which is both true or false at the same time. This is called paradox. We took a statement which could be either true or false, but cannot be same. And paradox is a sentence which is both true and false at the very same time. We have an example here. So the example says, here are the rules. And the first rule is ignore all the rules. This is called a paradox. Since it can't be true or false, we can't know the rules and then ignore all the rules. We can't follow the rules. We can't ignore the rules.
Your voice is again breaking up. I think it has something to do with your mic placement.
Yeah, I guess.
Yeah.
I'm holding it in the same place. It's still.
Yeah, now like now it's clear. Okay. Now it's clear.
Okay. Like example for paradox, here are the rules and then ignore all the rules. We can't follow the rules and then ignore all the rules. We can't do this, it's impossible. So it's called a paradox. Next, proposition. It's the notion or idea behind the statement. Proposition is the reason or the idea we're having a statement. For example, it is raining or it rains. This is a proposition. It's not a paradox. It's not true or false at the same time. Either it is a statement, either it is a statement that is, it cannot be either true or false. It is a proposition, the reason behind the statement. It is raining or it rains. This all will be clear just in a minute. Next, we have the truth value of a statement. We said a statement can be either true or false. So the truth or falsity of a statement is called as the truth value of a statement. It gives us shows us whether the truth value of the statement is true or false. When the statement is true, for example, we say roses are red, the sky is blue, then the truth value of that statement is true. We either write it as capital true or capital letter T. That is when a statement is true. When a statement is false, then the truth value of the statement will be false. We write it as capital false or capital F. So truth value of the statement shows us whether a statement is true or false. When it's true, we write it as capital true or capital T. And when it's false, we write it as capital false or capital F. Next, a statement can be a simple or compound statement. So here we have two types of statements. A statement can be either simple or compound. Simple statements, from the name, statements that cannot be broken down into two or more sentences. It consists of one sentence.
Can you try removing your earphone once? Can you try speaking? Because sometimes I think if you can remove your earphone, your laptop might catch your voice properly.
So simple statement cannot be broken down into two or more sentences. For example, we have 3 plus 3 equals to 6. This is a simple statement. We cannot again break it down into two or more statements. We cannot divide it. 3 plus 3 equals to 6. That's it. Another example, sky is blue. It's a simple statement and we cannot break it down. We can't write it sky and then blue alone because then it won't be a statement. Then it will be just a word. Next, compound statement. From the name, it signifies that a statement can be broken down into two or more sentences. This is called compound statements. And compound statements are formed by combining two or more simple statements. For example, we have here 3 plus 3 equals to 6 and New Jersey in India. This is called a compound statement consisting of two simple statements. 3 plus 3 equals to 6 is a simple statement. New Jersey in India is another simple statement, which are both combined together using the word and. And we can again break down this compound statement into two. 3 plus 3 equals to 6 and New Jersey in India. Is it clear so far? Does anyone have any doubt?
No, now your voice is clear. Please continue.
Okay. Now we start with basic logic connectives. We do connectives in English grammar, words that are used to join two or more sentences. Similarly, we have them in maths, basic logic connectives. Connectives are words that combine simple statements to form statements. Like the example we just mentioned here, 3 plus 3 equals to 6, in India. So connectives are words that combine simple statements to form compound statements, such as and. And is a connective that's used to combine two simple statements. 3 plus 3 is equal to 6. In India, we use and to join these two statements. Another connective is or. Earth is round or sky is blue. Both simple statements are connected using the connective or.
Can you explain what is the difference between connective statement and compound statement?
Okay. Compound statements made of two or more simple statements.
Oh, compound always have and.
Yeah,
Okay.
it have and or not anything, any connectives. Connectives are the words used to connect and or not
Okay.
if. These are the words for connecting.
Okay.
Connectives are the words used for connecting.
Okay.
Clear now?
Yes.
Okay. A logic connective is a simple which is used to connect two or more proportional variables. Suppose or and we are using it to connect two or more proportional variables. We have 5 logical connectives: disjunction, that is or, conjunction, and, negation, not, implication, if then, and biconditional, if only if. These are the 5 connectives used to join simple statements to form compound statements. Or, and, not, if then, if only if. We'll start first with conjunction. Conjunction uses the word and. If two simple statements, let's say P and Q, are connected by the word and, then the resulting compound statement P and Q is called a conjunction of P and Q. If two simple statements P and Q are connected by the word and, then the resulting compound statement.
Can you check once if your internet connection is okay? Maybe it's not your voice problem, it's because of internet it's happening. Can you check that?
Okay, can I just disconnect and connect again?
Yeah, you can do that also, right?
Okay, just a minute.
And everyone who is joined here, the meeting will end in 9 minutes 47 seconds. So you just need to click on the same link to rejoin, because we have 40 minutes time limit for one meeting in Zoom. So it will continue just like that. You just click on the same link, same joining link, and you will be again in the meeting. And I want you to know, guys, that David Todd, he is the guy who's editing our videos and uploading them on YouTube. So the credit goes to David Todd for doing that, for updating our sessions on YouTube. He just joined, I think.
Yeah, thanks, bro.
Just hang on, she will come. She was having some kind of network issue, I think. Yeah, now she has joined. I'll just make her the host again. It's Husnia. I get confused in their names. Okay. She will just start again. Your mic is mute, Husnia. You unmute it.
Is my voice clear now?
Yeah, so far we can hear you.
Okay. So we'll continue with conjunction.
Can you speak louder? Maybe if you speak louder, it will be okay.
So we'll continue with conjunction.
Yeah,
You
conjunction.
said if two simple statements P and Q are connected by the word and, then the resulting compound statement P and Q is called the conjunction of P and Q. We are using the word and to connect the statements P and Q, and this is called conjunction of P and Q. And we have a symbol for conjunction. It is this simple. I will just show you in a sec. So this is the symbol used to show conjunction. We write P conjunction Q. This is the symbol we use for conjunction. Let's take an example. Form the conjunction of the following simple statements. We have two simple statements, P and Q. P says Ali is a boy, and Q says Sarah is a girl. We need to connect these two simple statements to form a compound statement using conjunction, that is using and. So the solution will be P conjunction Q, or P and Q. This is the simple we're using. Ali is a boy and Sarah is a girl. Here Sarah is the conjunction and. Is it clear? Sorry, and is the conjunction. Sarah is a girl. Next, we have disjunction. If two simple statements P and Q are connected by the word or, then the resulting compound statement P or Q is called disjunction of the statement P and Q. And the symbol for disjunction is capital V, the opposite of conjunction, capital V. For example, we have the statement P, the sun shines, and Q, it rains. We need to connect P and Q using disjunction, using the word or. So the answer will be P disjunction Q, or P or Q, the sun shines or it rains, or is the disjunction used to join the simple statements. To join المشكلة connect. So P or Q, or we can say P disjunction Q. Can you hear me?
Yeah, we can hear you.
Okay. So So Husna disconnected, so the net will be better for me. Okay. So we finished conjunction and the symbol is V but inverted, like the opposite side V. Disjunction or, and the symbol is capital V. And next we have negation. What is negation? An assertion that a statement fails or denial of a statement is called the negation of the statement. Negation of the statement is the denial of the statement or not of the statement. The negation of a statement is generally formed by introducing the word not. In conjunction we use and, disjunction we use or, in negation we use not. For example, and the symbol for negation is this. This is the symbol for negation. Okay. We have an example. Statement P, New Delhi is a city. We need the negation of statement P. So we will say negation P, New Delhi is not a city. Not is the negation used. This is negation of a simple statement. Now we'll see negation of compound statements. Here we have only one statement P. So it's a simple statement. New Delhi is a city cannot be broken down again into two sentences. So it's a simple statement and the negation of a simple statement using not. Now we see negation of a compound statement. Negation of conjunction. The negation of the conjunction means the negation of at least one of the two substatements when we use not in a compound statement that have a conjunction, then it will give us a negation of the disjunction. That is negation of P and Q is equals to negation of P or negation of Q. It will be clear with the examples coming. Next, negation of a disjunction. The negation of disjunction would mean negation of both P and Q simultaneously. It's kind of the opposite. Negation of P or Q is equals to negation P and negation Q. This is the easiest one. Negation of a negation is the opposite of the given statement, or negation of the negation is the statement itself. How is that negation of the negation give us the statement itself? It will be clear with the example. Negation of negation P is equals to P. For example, we have the statement P, it rains. Negation of P will be it does not rains. And negation of that negation P again will be it rains. That is the statement itself. I'll show an example. Here. We have the statement P, New Delhi is a city. The negation of P will be New Delhi is not a city. Again, when we use negation in negation P, it will give us the result New Delhi is a city. So negation of a negation is the statement itself. Is it clear so far? Is it clear or do I have to repeat anything?
No, your voice is fine now. It's clear. If anyone has any doubts, you can unmute and ask. She is explaining the concepts.
Any doubts so far?
Nope.
Okay, nice. So next we have De Morgan's law. This is an important law in mathematical logic.
Preeti, do you want to ask anything? You unmuted your mic.
No, I'm good.
Okay.
Okay. De Morgan's law. When we take negation of conjunction and negation of a disjunction, it is called De Morgan's law. When we take the negation of conjunction and the negation of disjunction, or then we get the De Morgan's law. First, we'll start with negation of a conjunction, negation of and. That is negation of P and Q is logically equivalent to negation of P or
Sundar,
negation of
mute
Q.
yourself.
We have the example, Paris is in France and London is in England. This is a statement. So first, can anyone tell me, is it a simple or a compound statement?
Compound statement.
Okay, compound statement. And it is joined using a conjunction or disjunction?
Conjunction.
Conjunction. And we have Paris is in France and London is in England, which is a conjunction joined by the word and. Compound statement joined by the word and is conjunction. So let's break it into first. Let's say statement P, Paris is in France.
Your voice is again breaking up, Husnia.
Okay. So let's say statement P, Paris is in France. Q, London is in England. We broke the compound statement into two simple statements. Then the conjunction is given by P and Q, the conjunction of P and Q. We got the conjunction P and Q. Now we need to find the negation of P and negation of Q. So negation of P will be Paris is not in France. And negation of Q would be London is not in England. So by using De Morgan's law, here, this simple, what does it show? Negation or conjunction? The simple capital V.
Conjunction, I think. Or negation.
It's disjunction.
It's disjunction, that is or. It's disjunction. So we're gonna join these two sentences, the negation using or. So it becomes Paris is not in France or London is not in England. That's how we used the formula negation of a conjunction using De Morgan's law.
We can also use
have a
and
compound
in place of
statement.
that, right? No.
Yes, this is negation. This is of conjunction. Next, we will do disjunction also.
No, I'm saying
Here a conjunction.
I'm saying like yeah, Paris is not in France and London is not in France, England. So we can also use and instead of or we have to use or only.
No, we are here using or because according to the law, when we are using P and Q, then it will be P negation of P or negation of Q. It won't be negation of P and negation of Q.
Okay.
We are following the law. Okay.
Okay.
We are following the law. It's like the opposite. When using and, we'll use or.
Okay.
Got it?
Hmm.
Okay. Now we are doing negation of disjunction. That's when we are using or, it will give us negation of P and negation of Q. Again, we have a statement. Ram is in class 10 or Sam is in class 12. Here you having a compound statement that is joined using or, disjunction. We are going to break this sentence into two simple sentences. Statement P, Ram is in class 10, and Q, Sam is in class 12. So using De Morgan's law, conjunction of P will be Ram is not in class 10. We are just using the conjunction, using not. And conjunction of Q, Sam is not in class 12. So according to the formula, negation of P or Q. So according to the formula, negation of P or Q is logically equivalent to negation of P and Q. Negation of P, Ram is not in class 10 and, sorry, this is supposed to be Sam. Yeah. So negation, it will be negation of P, Ram is not in class 10 and negation of Q, Sam is not in class 12. This is the use of De Morgan's law. This is the second one. Is it clear?
Yeah.
Any doubts so far? So all these disjunctions and conjunctions and negations, De Morgan's law, we will all start using it when we start the truth table. Truth table.
And it's better if we start the truth table in the next session if it is possible. And now if there is any doubt, I can answer it. Any doubts?
None so far.
Yes, of course.
Is there any problem?
About the important stuffs. So we said a statement. A statement is a sentence which could be either true or false, but it cannot be both simultaneously. A statement cannot be true and false at the same time. This is called a sentence cannot be true and false at the same time. So this is called a statement. It should be either true or either false. Example of true statements: 2 plus 2 is 4. This is a true statement. An example of false statement: Moon is a planet. This is a false statement. Paradox is a sentence which could be both true or false. Sorry, true and false at the same time. Paradox is a sentence which is both true and false at the same time. Like we have an example, here are the rules and ignore all the rules. We can follow the rules and ignore all the rules at the same time. So this is called a paradox. Proposition is the notion or the idea behind the statement. The reason we have the statement is called proposition. For example, it is raining or it rains. Truth value of a statement. The truth or falsity of a statement is called the truth value of the statement. The truth value of the statement gives us or show us whether a statement is true or false. When the statement is true, then the truth value of the statement is true. We can represent it either by capital true or capital T. And when a statement is false, then the truth value of the statement will be false. It can be represented by capital false or capital F. A next statement can be a simple statement or a compound statement. When we say simple statements are the statements that cannot be broken down into two or more sentences. For example, 3 plus 3 equals to 6 is a simple statement and we cannot break it down furthermore. Whereas a compound statement can be broken down into two or more statements, sentence that can be broken down, and they are formed by two or more simple statements. On this statement, we use two or more simple statements. For example, 3 plus 3 equals to 6, and New Jersey is in India. These two are simple statements, and we are joining them using the word and to form a compound statement. And this compound statement can be again broken down into simple statements. 3 plus 3 equals to 6, New Jersey in India. Basic logic connectives. We have the connectives. Connectives are the words that use to combine simple statements to form a compound statement. We can use either and or. 3 plus 3 and 3 plus 3 equals to 6, and New Jersey in India is a compound statement that is joined using the word and or earth is round or sky is blue is also a compound statement joined using the word or. The connectives or. And we have 5 logical connectives: disjunction or, conjunction and, negation not, implication if then, biconditional if only if. And we first started with conjunction, that is and. If we have two simple statements P and Q, and they are connected by the word and the resulting compound statement will be conjunction of P and Q. And the symbol is inverted V. Use the simple P and Q, inverted V. For example, we have the statement P, Ali is a boy, Q, Sarah is a girl. When we say P and Q or P conjunction Q, we say Ali is a boy and Sarah is a girl. We're using the word and, the connective and, to form a conjunction statement. Disjunction, when we have simple statements P and Q, they are connected by the word or, then the resulting compound statement will be called disjunction of P and Q. And the symbolic form for disjunction is V, capital letter V. P or V, or we can say P disjunction Q. We have example, the statement P, the sun shines, Q, it rains. P or Q, P disjunction Q will be the sun shines or it rains. Negation. Negation is the denial of the statements. When we deny a statement, then it's called a negation. We use the connective not. We have an example, and the symbolic form for negation is the symbol we use it before the statement. Negation P. We call it negation P. We have an example, P, New Delhi is a city. Negation of P would be New Delhi is not a city. We know this statement P, New Delhi is a city, is a simple statement. So we can use negation as simple statement, and we can also use it in a compound statement. When we use negation in the compound statement, it changes. When we have negation of P, when you have negation of P and Q is equals to negation of P or negation Q. And negation of disjunction, negation of P or Q equals to negation of P and negation Q. Next, negation of a negation. That is, we are denying the negation itself. So this gives us the statement itself. We have negation of negation P is equals to P itself. We can say that the negations cancel each other and only the statements remain. The same statements remains. Next, we have De Morgan's law. When we take negation of a conjunction and negation of a disjunction, then it gives us De Morgan's law, or it forms De Morgan's law. First, we say negation of a conjunction. We are denying the conjunction. When we deny the conjunction, it gives us the disjunction. For example, we have Paris is in France and London is in England. This is a compound statement and it is connected using the conjunction and. It is a conjunction and. So let's say P, Paris is in France, and Q, London is in England. Next, we need to find the negation of P and negation of Q. Negation of P would be Paris is not in France, and negation of Q, London is not in England. And according to De Morgan's law, when we find the negation, we need to use the connective negation or not. Or. So we say Paris is not in France or London is not in England. Negation of a disjunction, negation of P or logic equivalent to negation of P and negation of Q. We have here also an example. Ram is in class 10 or Sam is in class 12. Statement not using the connective or this disjunction or. P, Ram is in class 10 and Q, Sam is in class 12. We are now finding the disjunction of P and disjunction of Q. Disjunction of P would be Ram is not in class 10. We are using not because the connective for the the connectives for the disjunction. And negation for the negation. And negation of Q, Sam is not in class 12. Now, following the De Morgan's law, negation of P and negation of Q. So we'll connect these two sentences using and. Ram is not in class 10 and Sam is not in class 12. Is it clear so far?